Now let's look at robotic locomotion, but specifically let's look at programming our Taskbot to perform some movements. So when you first start doing this, one of the best ways to think about it is to give yourself a task. Okay, so a task for the Taskbot to do. And let's just look at some of these simple courses that we might, some of these simple courses that we might have our robot do. So for example, we are going to program our robot to go forward and stop in some circle, okay? Or we might program it, a little bit more sophisticated challenge would be, let's say there's an obstacle that we'll put out there, coffee cup, for example. And you're gonna go up, turn left, and then go to the where you wanna be. And then you could have two obstacles. And then finally, a good place to start is the square. Okay, so you can kind of see that these tasks are going to be something where it's a sequence. Okay, so this one, when you start with this, you're just going to go a sequence, and we're going to get familiar with programming the robot over and over in order to just get familiar with how far does it go when you actually say go for 3 rotations of the wheel. And how do things like telling it to go fast versus slow impact things? Same thing here. We're going to learn about turning radius and settings with turns. Same thing here. But when you do these turns, we're actually going to have a sequence of tasks or a sequence of operations. So we might go forward, turn left, go forward. This one we might go forward, turn left, forward, turn right, forward. And this final one is something that we could do, and we could do it as a sequence of tasks or operations, but we could also do it as a loop. So you could potentially do that. And this is really cool when you're working with students to give them something to do. So it's not just about programming the robot to move around randomly. You can set these up on the floor with masking tape, and you can have all these different obstacles, put about 10 or 11 of these out, or however many you want to do, and give them a ever-increasing level of complexity to solve these things. And it's really an interesting thing to watch, because the students design a program, they run it, and it doesn't work, and then they go back, modify the program, and you just kind of see the wheels turning in their heads of, oh, that's what I did this last time, and that's what I did this time, and this is what I need to do. So you just get in this iterative process of making sure that the program works to accomplish the task. And sometimes people will say, we're going to set up a golf course. So you set up 9 or 18 of these on the floor of a big room, and you have a group full of students, and maybe they each one has, 3 attempts to do it, or you go to each particular task or obstacle and you keep track of how many times it took to go from the start to the finish, and then the lowest score wins. So there's all sorts of games and competitions that you can do this with. Okay, so the first step we're going to do is let's bring up our LEGO Mindstorms NXT software, and this is the screen that comes up. So we're going to create a new program, and you can save all these programs. You can save as many as you save each one as a file. So if you get a program that works, go ahead and save it. So let's just call this Loco. We'll go Loco 1 for Locomotion 1, and then I'm going to say go. And you can download a handful of these programs to the NXT robot itself. Okay, so here we are. Here's our blank graphical programming interface. And the motions are found in a couple different places. So if you come up to the common menu here, you're going to see a move, you're going to see a record, play, sound, display, wait, loop, switch. These are the most common ones. But the move is really interesting because it is the one that we use for our Taskbot. So what I'm going to do is I'm going to bring it down, and this right here, this piece right here to the left that's always on the screen, that's what the start. Okay, and then we're going to come over here and we're going to drop it down there. This particular widget, or this particular operation, it's a block that assumes you have 2 motors which are controlling your wheels. And that is indeed the case with the Taskbot. It tells you, or it has options down here, whether you have B and C connected or A and C or whatever, but you get to choose 2 of these at any given time. And then you get to set the direction. So depending on how you build it, sometimes you might have the servo motors rotated a certain way, so when you think you're going forward, you're actually going backwards. So you come in here and you actually just can change it really easily. And then they give you the ability to steer. So you can use the same block to not only drive forward or backwards, but you can use it to steer. And so this block is very useful. You're going to use it over and over and over, but it's used to perform one movement task. Okay. You also have motor control over here under this this action menu, and let me show you the difference. If I drag this down, notice that I'm going to drag this over here, and it's not connected to anything. So when you run your program, it's going to start here, it's going to execute this, and it will just stop. It's not going to run this. If I wanted this task or this operation to be executed, I have to bring it over and actually connect it, so you can actually see the robotics or the pieces connected. If I click on this, notice that it's only going to allow you to control one motor at a time. So you could do a whole bunch of different things if you wanted to. For example, you could have two of these single motor controller blocks, and you could actually have one control your left motor and one control your right motor. But this block right here is this move block it's when you have two motors, so it's really handy to do. Okay, all right, so I'm going to go ahead. One of the things that you might have seen me do is I clicked on this and I did a copy and paste. So you can come up here and go edit, copy, and then just click somewhere else and go edit, paste. And we'll use that a lot once you get one of these set up, once you get a block set up the way you want it. You can delete them just by deleting them. The copy and paste also works if you do Control-C and then Control-V, just like in a word processor. Okay, or just in Windows operating system. Okay, so I'm going to delete all these. And let's take a look at making this thing go. So I'm going to come down here and I'm going to leave the B and C, and I'm going to leave the direction correct, or the direction is forward, and we'll see if it moves forward. Then I'm going to have my power, and this is an important setting. Okay, so I'm going to put this at 50% power just because they can move pretty fast. And for the duration, I'm going to do it in terms of seconds. Notice that you can do it in degrees, rotations, and seconds. And this is really a neat way to you can illustrate things such as the circumference of the wheel, and you can use some geometry to calculate exactly how far the robot will move based on the number of rotations. So you can really stress some of these mathematical skills. I'm just going to do it for seconds, and I'm just going to guess that it's 2 seconds. This one is really interesting too, because you can have the robot go, and as soon as it's done with its 2 seconds, you can just hit the brakes and it'll stop, or you can coast. And it's really interesting because this robot has mass, so when you get done moving, it will have momentum and it will try to carry forward. Even when you put the brake on, the wheels will just skid. And so when you try to do these little tasks, these obstacle courses, it's interesting to see how the momentum and how the mass of the robot affects what your program is going to do. So let me put coast on here just to see what's going to happen. And I'm now done. I have a program, and what I want to do is I want to download this. So I'm going to grab my Taskbot, and what I'm going to do is I'm going to connect the USB to it, and then what I'm going to do is I'm going to turn it on, and it'll make its noise, and it is now connected and ready to be programmed. So I'm going to come over here. Remember, you don't want to hit play. That'll download and run, and it's still connected to the cable, so it'll take off. So I'm going to go ahead and go download. It compiles it, downloads it. It'll beep when it's complete. And now what I'm going to do is I'll disconnect my cable, and I'm going to come over to NXT program on the robot, or I'm sorry, not NXT program. You're going to go under My Files, and then go Software Files, and then you'll see your Loco 1 on there. And now when I select it, it's ready to run. So what I did on my desk here is I went ahead and put my finish right here. So I'm going to try to land this robot on this little white block there, and then I'm going to have a start position, which I'll dictate with this tape, and let's just see how far it's going to go. Okay, let's just see what happens when I run this. So it made it about half of the way. All right, so then the task now is, okay, let's change the program. So I connect it up again, and what I think I want to do is double the amount of time that it went. So I come in here, and I'm going to go ahead and make it 4, and then we'll go ahead and download it. And let's stop for a second here. Okay, so I'm going to go ahead and download it. It downloads my new program. And I'm ready now to disconnect and see how this worked. Okay, so let's see how we're doing. And we got our Loco right there, and we're going to go ahead and hit run. and it did it. Okay, so that was pretty easy. It did take a couple different iterations, but it ended up working. Okay, so this is good. So I'm going to go ahead and plug my robot back in, and this way we'll be ready to do a program. But now let's do something where we're going to go and we're going to turn and then go to the end. Okay, so let's take a look at how you would make a turn on here. So what I'm going to do is I'm going to copy this motion block, this move block, and I'm going to put it right here. And what I want to do is I want to move forward, and let's take our move forward back to 2 seconds. So the speed was pretty good. The speed going at about 50% was fast enough. And then what I'm going to do is I want to turn left. Okay, so what I'm going to do is I just come down here, and you can use this drag bar right here. You can drag this little slider, and you can see different levels of turn. So using this little arrow right here. What's really interesting is if you go all the way, it'll actually perform a different type of turn. So instead of moving forward and turning left, it'll actually it'll back up a certain way. So you can actually have your robot go forward and then back up and then go like that. Okay, so I'm going to do a pretty crisp turn, and this is one where you still tell it what duration of time you want to do for the turn. So let me do 1 second, and let's just see what happens when I do this. Okay, so I'm going to have this go for 2 seconds straight, and I'm going to go turn a little bit, and let's go ahead, and I can save from time to time, just save my robot there. And so I'll go ahead and download this, and it's ready to go. And so now what I'm going to do is I'm going to set up my obstacle course where I want to go forward a little bit, and I'll put my start line right here, and I'm going to go up, and then I'm going to turn left and see if I can be pointing roughly in the right direction. So I'll go ahead and come on here, and goes forward, turned right. Okay, it turned right. That is not what I expected. So that's fine. So what we have to do now is we have to think about why that went right. So it must have to do with that the B and the C are, let's think about this here. Let's think about this. Okay, so when I move this around, what I need to do is tell it which one's on the left and which one's on the right. So I'm going to switch these and have C be on the left and B be on the right. When we went forward, it didn't really matter, but when we want to steer, we want the arrows to correspond to where we are. So let's go ahead and let's try this again. I've switched the motors, or switched where the motors were, and it didn't turn very good. It basically did not do a 90-degree turn. So I'm going to give it a little bit more there, and let me go ahead and do 2 seconds there, and then we're about there. So what I'm going to do is let's put one more motion after it and see if we can go straight for 2 seconds. So this is what these programs look like. They just look like these blocks, and they're kind of hard to read when they're just motions or moves because you have to click on them to see what's going on. But I have a move forward, then I have a turn left, and then I have a move forward. So I'm ready to test this out again. So let's go ahead and plug this in and go ahead and download. And every once in a while the USB it will not recognize the NXT, so you just have to unplug it and plug it in again. Okay, so here we go. We're ready to go. I'm going to go ahead and run my program and see what happens. Turns left and missed it. Now that did not turn, it turned too much. So now all I do here is come in here and I'm going to say instead of turning for 2, I'm going to turn it for 1.5. All right, so you can see the process here. So this is kind of a fun, interactive robot programming task here. So you can imagine that you have a classroom full of students doing this, and it just becomes just a blast. Okay, so I did it. Everything is great. Life is good. Okay, so if you come back to what we did, we accomplished this. You know, we forgot our obstacle on here. So hang on, let's do this. We forgot our obstacle that we were going to go around. So we had this obstacle, and that was the whole point, was we wanted to avoid that obstacle. So let's go ahead, and I'm going to try to get to where I need to go, but I can't run into the bottle. So I was able to do it. Piece of cake. All right, life is good. Now you could do the same thing with 2 obstacles, and I'll leave that for you to do. But let's look at this one right here. This is going to be something that I could easily do. I could go forward, turn left, forward, turn left, forward, turn left. However, wouldn't it be neat to try to do this in a loop? So let's look at the programming constructs. The first thing that I have here, which is kind of neat, is I have created a turn, it turns very nicely 90 degrees left, so I don't need to mess with that. And I also have a straight, which basically gets from here up to about here. So I have the 2 motions that I want, and really what I want to do is I just want to loop them. So let's take a look at how we could loop it. So let me delete this last block. So I have a move forward for a little bit, turn left, and then move forward, turn left. And what I want to do is I want to create a loop. So I'm going to come over here, and I am going to go to my common menu, and I come out here, and here's the loop structure. Now the way that the loop structure is you encompass things, okay? So notice that when I drag it around, it tries to move these things. So what I want to do is I want to put it right at the beginning for this particular case. And then I want to drag the loop. And you don't drag the loop, you drag things into it. So as soon as I drag this into it, the loop gets larger, and then the loop gets larger. So now I have the ability, I have a loop construct on here, but I can change settings on the loop by clicking on this left portion. So when I do it, so I'm gonna repeat this program. I'm gonna loop, okay? So let's come down here and let's see what controls I have. I have control forever. Well, let's not do that. Let's go count, and I want to do it how many times? Let's do it 4 times and see if this will actually go in a square. Okay, all right, so let's go ahead and download this and see what happens. So I download it. Okay, it is ready to go. And we'll see if we can do this without running off the table. Okay, notice that one of the things I do with the Taskbot is when I start the wobble wheel, or this is this rotational wheel, I think it's called the wobble wheel. I always start it in the right position. If I start it like this, my robot will start when I do that. So that's something to guide students on. Okay, so here's my thing, and I'm ready to go. Let's see what happens. Goes up, turns left. Goes forward, turns left. Goes forward, it's going to fall off the table. Turns left. And I'm almost back to where I started from. And there it stopped, okay? So it almost did a square, okay? It almost did a square, but more importantly, we studied the loop structure. So in this situation, we've covered 2 of the 3 programming constructs, that is the sequence and also the loop. In this situation, it was a conditional loop. It only looped 4 times. It could have been an unconditional loop, but it wasn't. We could have had a loop forever and say that. But at this point, you know how to get this Taskbot moving, and you can start doing all sorts of really fun and exciting things, avoiding obstacles, doing, cruising around the hallways. So we're up and moving, we're learning how to program. It is very iterative. You can spend a lot of time in the program calculating what's going on and calculating circumference of wheels and stuff like that, but at the same time it's also fun just to try it. It's something where it's a platform that's designed to just be iterative, just program and test, program and test, program and test. Okay, so at this point we now have completed our locomotion module. Okay, so we have 2 small checks now, which mean 1 big check. We have looked at the DC motor and the theory behind it and just the terminology of what's going on, and that is what's used in the LEGO Mindstorms. We use a DC motor, but it's in the form of a step or a servo motor. So within that big assembly is technically a servo motor. And then we looked at programming the robot to move, and we looked at some turns, and we looked at all sorts of things. And so what I encourage you to do is take a minute and try to just create a few tasks, a few real basic things. Move, put some tape on the ground, try to follow the line just using timing, and just see what it's like to do iterative things. Maybe walk back, try this one right here. Okay, try this obstacle, move in between 2 obstacles, make a more complicated obstacle, just get some experience messing around with this, because it really is fun. And then the next thing we'll do is we'll look at attaching the sensors to the Mindstorm, and we'll see how we can actually make an even more sophisticated program when we allow the robot to respond to its environment.